Hey guys, kind of here. So today we're going to finish up our big three in terms of pollution. Today we're going to be looking at air pollution, its causes, effects, and solutions, just like we did with going over land and water. So what are our essential questions for today? Number one, what are the four main types of air pollution sources? So we'll look at where the air pollution comes from, and then we'll talk about how it impacts things. Number two, what are the four main types of effects of air pollution? So now we've got air pollution. What are the outcomes? What things happen as a result of that? And number three, what is acid deposition? What are its effects? Now, you may be more familiar with the term acid rain. Acid deposition includes acid rain, but applies to more forms of precipitation than just rain. And then number four, how can you get involved to improve air quality and reduce air pollution? I've structured this very similarly to the previous two sets of notes so that we can go ahead and kind of look at the similarities between the three different types of pollution, as well as the overlap in terms of the sources and effects. Let's start out with looking at air pollution. So air pollution consists of gases, liquids, or particles in the air that can have serious effects on human health, wildlife, vegetation, lakes, streams, soils, and visibility. Whether an air pollutant is a problem depends on just how much of it there is and how long it stays around, and in some cases, the weather. Warmer weather can cause problems. We'll talk more later about certain types of smog that are more problematic when you have warmer weather. We can talk about the fact that inversion layers help to trap some of those pollutants in so they can become more concentrated, things along those lines. The Environmental Protection Agency, or EPA, has set national ambient air quality standards for several pollutants in order to protect public health and the environment. Some of the protected particles that we look at are fine particles, sulfur dioxide, nitrogen oxides. This includes both nitrogen oxide and nitrogen dioxide, ground level ozone, carbon monoxide, and lead. Let's take a look at some of those and where they come from. The air pollutants of concern include the following. Number one is ground level ozone. Yes, this is the same ozone that exists up in the ozone layer, but it is not good for us to be around and for us to interact with. It protects us from ultraviolet lights up in the upper atmosphere, but in lower level forms, it is created when volatile organic compounds, like things from gasoline or solvents and vegetation, react with nitrogen oxide emissions in the presence of sunlight. This is different from the ozone layer in the upper atmosphere, which protects us from the harmful UV. Sulfur and nitrogen. Remember that most of our atmosphere is made up of nitrogen. So when sulfur and nitrogen compounds of particular types, especially sulfur dioxide and nitrogen oxide and nitrogen dioxide, are produced by power plants and factories. Additional nitrogen pollution can come from cars and agricultural sources, including crop fertilizer and animal wastes. Particle pollution comes from wind-blown dust and smoke from burning fossil fuels, as well as from forest and grassland fires, even ash and smoke coming from a volcanic eruption. Other ones include toxic compounds, including metal, mercury is a good example of this, and chemicals such as pesticides. Most human-caused mercury in the atmosphere comes from coal-burning power plants. Toxic chemicals come mainly from the production and use of agricultural and consumer products. And then lastly, which we'll spend more time on at the end of this unit, is greenhouse gases. These are things that contribute to human-caused climate change, including carbon dioxide from burning fossil fuels and biomass, methane from livestock operations, black carbon from incomplete combustion of said fossil fuels, and even ground level ozone. So, what are the activities that are primary producers of these things? We've mentioned some in terms of agriculture, which is a big one again for air and soil. I mean, water and soil. We also talked about power generation, especially coal burning power plants, industry of various types coming from factories, urbanization, and all the things associated with that, and then natural sources, which we didn't talk as much about when we were going over water and when we were going over land, but there are natural sources of air pollution like the volcanic eruption I mentioned before. So here is the list. Agricultural activities. industry and power generation, urbanization, and natural sources. The causes of air pollution are very similar to the list we saw for both land and water pollution. And please remember that all three are interconnected. In many cases, pollution in one leads to pollution in the others. Also, like land and water pollution, prevention is preferable to cure, and it's much easier in most cases to not pollute than it is to clean up the pollution that does end up there. All right, so where do these come from in terms of being able to identify the source of the pollution and being able to track it? Because air is in particles and is more of a gas in most cases than what we saw in liquid with water and what we saw in solids with land, it's a little bit harder to track in many cases. We found good ways to go ahead and monitor and follow this, but it's definitely an issue we need to deal with. Okay. All of the causes of pollution on the previous slides can be classified based on their area of effect. There are four main types of air pollution sources. The first are mobile sources, things that don't stay put, things that move, such as cars, buses, planes, trains, trucks, so on and so forth. Stationary sources are those that stay in one place, things like power plants, oil refineries, industrial factories, these types of things. Area sources are things that are not typically identified to a single production point, but are accumulated over certain areas and have a magnified effect from their combined impact. Things like agricultural areas, cities, wood burning fireplaces, these types of things, where it's not one fireplace that's causing the problem, it's all of the fireplaces. It's not one car that's causing the problem or one farm that's causing the problem. It's multiples and they're added up effects. And then the last one is our natural sources, such as windblown dust, wildfires, and volcanoes, which we can go ahead and look at as both stationary sources and area sources, depending on the problem. So when we look at these, we can see that all of them contribute pollutant emissions. Mobile sources, as you see over there on the right, account for more than half of the air pollution in the United States. And the primary mobile source of air pollution is the automobile. This is according to the Environmental Protection Agency. We also have in the next over there some stationary sources like power plants. These emit large amounts of pollution from a single location and are a type of point source pollution. If you remember our point source versus non-point sources. Area sources, like you see in the second from the left there, are made up of a lot of smaller pollution sources that aren't a big deal by themselves, but when considered as a group can be. These are what we termed non-point sources of pollution. Natural sources can sometimes be significant, but do not usually create ongoing air pollution problems like the other sources that we just talked about there. But you can see in there lightning, volcanoes, wildfires, so on and so forth. So let's start with probably one of the biggest ones. And this is one that's been a problem for all three types of pollution, and that's agriculture. When we removed animals and plants from being part of the same agricultural production process and we started doing monocultures, we ended up with big problems in both animal and plant production. Animals like cows and sheep release massive amounts of methane through belching and breaking wind. Methane is a colorless gas which is produced in their stomachs when bacteria break down the food that they eat. Remember, cows are hindgut ruminants. Across the whole world, livestock is the biggest source of methane, and methane is the second most important greenhouse gas which can cause climate change. We'll talk more about this in the second half of this semester. The next big one is industry and power generation. During the Industrial Revolution, lots of factories were built near large towns and cities. Today, the main industrial hubs tend to be in the countryside, away from cities, so there are fewer people around because of the amount of pollution that most of these factories produce. Nitrogen dioxide and sulfur dioxide are the two main pollutants associated with industrial processes, but there are others. And that's not just for air, but also for water and land. To generate electricity, fuels such as coal, gas, or oil are burned at power stations. When these fuels are burnt, they release nitrogen oxides, sulfur dioxide, and particulate matter, as well as greenhouse gases, which can cause climate change. Again, I know it keeps coming up, but I'm not going to focus on greenhouse gases and climate change here. I'm going to save them for notes that we have later on this unit. So let's take a look at those different molecules that we mentioned, the sulfur dioxide and nitrogen dioxide in particular. Sulfur dioxide is a gas. It is invisible, has a nasty, sharp smell to it, and reacts easily with other substances to form harmful compounds, including sulfuric acid, sulfurous acid, and sulfate particles. Now, sulfuric acid is one of the main contributors to acid rain, which we'll talk about here in a little bit. It's released naturally by volcanic activity and is produced by byproduct of copper extraction and the burning of fossil fuels contaminated with sulfur compounds. Again, coal being a primary example of this. About 99% of the sulfur dioxide in the air comes from human sources. 99, so that's the vast majority of it. This particular form of pollution can be very easily linked to human processes. Sulfur dioxide also affects human health. So when it's breathed in, it irritates airways, can cause coughing, wheezing, shortness of breath, or even a tight feeling around the chest. If you've ever been in a super crowded city, see, it's tough now because we have so many more restrictions on air pollution. But I remember when I was younger, some of the biggest cities had a lot of smog, and just walking around the streets could be irritating to the lungs. If you were to go to places like Beijing or Mexico City, these are places that still have some of these uh, horrible air conditions where you still can feel that kind of stress on your respiratory system. Then we get nitrogen oxides. Nitrogen oxides are really a group of 7 gases or compounds, but the two most common, which we're going to talk about here, are nitric oxide, NO, and nitrogen dioxide, NO2. Nitrous oxide, more commonly known as laughing gas, is a greenhouse gas that contributes to global warming. Nitrogen oxide pollution is emitted from vehicle exhaust and the burning of coal, oil, diesel fuel, and natural gas, especially from electric power plants. They are also emitted by cigarettes, gas stoves, kerosene heaters, and wood burning. Nitrogen oxides can create environmental health hazards when they react with sunlight and other chemicals to form smog. Okay, so keep that in mind when we start looking at nitrogen oxide. So nitrogen oxides can create environmental health hazards when they react with sunlight and other chemicals to form smog. Nitrogen oxides and sulfur dioxide react with substances in the atmosphere to form acid rain, which again we'll talk about here in a minute. Okay, nitrogen dioxide is used to produce rocket fuels and explosives. Nitrous oxide is emitted during agricultural industrial activities and during combustion of fossil fuels and solid waste. Additionally, it can be used as an anesthetic. I don't know too many places that use it still as an anesthetic. When I was a kid, they still used it sometimes in like the dentist's office, but it's falling out of popularity with many doctors, so you don't see as much use of it. The health effects of nitrogen oxides, whether it's nitrous oxide or nitrogen dioxide, are very similar to those in terms of sulfur dioxide. So you're having respiratory effects primarily, wheezing, hard time breathing, pain, tightness in the chest. So the last category we wanted to list were your natural sources. Some of the natural sources of air pollution are organic compounds from the plants, sea salts, suspended soils, dusts, say from a dust storm in the Sahara. Other natural sources are released during catastrophes such as volcanic eruptions and forest fires. Large amounts of harmful gases and smoke are released, which can increase background pollution levels for years, even in areas away from the original source. I think about eruptions like Mount St. Helens when that blew. The ash from that eruption actually was able to make it all the way around the world. So they were able to detect levels of increased air pollution and ash as far away as Russia and Siberia before it circled all the way back around. I actually have some ash from Mount St. Helens that I got from my aunt, but she was in Montana, and so she actually just collected it off the top of her car because it blew over following its eruption. One of the most common natural air pollutants, though, is ozone, because you do see some forming of ground level ozone as a result of chemical reactions in the lower atmosphere. All right. Now, I also want to remind you that, like with water pollution, it does not stay put. Air pollution and water pollution, anything that's in a fluid like that, is going to move. So pollution from human generated and natural sources is often created in one place and transported through the air or through the water to somewhere else. We all kind of live downstream. Sometimes chemical reactions in the atmosphere can change air pollutants before they're even deposited, so that you can put up one, what we would call a primary pollutant, and it would be converted into a secondary pollutant before it actually falls back to the ground. Okay. Pollutants in the air then can recreate haze. You can go ahead and make it harder to see. Pollutants can cause depositions and have biological effects. Location and even time of the year can determine which pollution sources are the most important to a particular location. As you can see in the diagram here, we talk about that deposition, whether that's rain, snow, sleet, hail. We see the haze there. You can talk about the biological effects there as well. So let's start talking a little bit more about the effects. There are four main types of effects caused by air pollution: visibility, ecological, human health, and economic. Um, I will go over visibility a little bit, and then I'll kind of quickly go through the others, but I think many of them you can probably think through on your own. Air pollution can create a white or brown haze in the air that affects how far we can see. It also affects how well we are able to see the colors, shapes, and textures of what we're looking at. Haze is caused when sunlight encounters tiny particles in the air. The particles scatter light out into and out of the sight path and absorb some of the light before it reaches your eyes. The more particles in the air, the more scattering and absorption of light, reducing the clarity and colors of what you see. Some types of particles scatter more light, especially when it's humid, which means there's more water vapor in the air. So again, we're dealing with more particles. So these are actually pictures taken down in the Mills Hills in Northern California when I was back there for college. The picture on the left is a good visibility day, so you can see pretty far, a lot of the mountains into the distance. And then the one on the right is a day when there was a lot of kind of pollution in the air. That's the haze that we're talking about. It can affect visibility, dull national park views, soften textures, fade colors, and sometimes it does some neat things for photographers, but by and large, it's not helpful. This is how that works. The light is coming down and it gets scattered off of particles, because remember, what you see is the light reflected off objects. But if that light doesn't all make it to your eye, or you end up getting other light coming to your eye that's not off that object, what you see is not an actual representation of what's there. So this kind of reflection and absorption really changes what we see. This is an example, obviously not from the United States, but you can see how far you can't see, right? A lot of it is blocked off by the haze in the air. So what does it look like? Well, it can come in typically one of three forms. You can have haze in the form of a plume if you've ever looked through a smokestack. You can have layered haze where the temperature kind of traps it below, like a cooler body of air. And so you end up with kind of a little lower layer of it. And then uniform haze, like we saw in that picture before, where it's just kind of everywhere. Okay. So these are your four types that we'll look at: a clear day, plume, layered haze, and uniform haze. Recognizing that plumes and layers can mix with the surrounding atmosphere, creating a uniform haze or overall decline in air clarity. Plumes and layered haze are more common during cold winter months when the atmosphere moves less. So let's start here. So a plume looks like this, is a column-shaped layer of air pollution coming from a point source, such as smokestack. When you go ahead and look at this picture, you can see from that particular one that everything looks clear except the things that are right behind the plume. Then you get layered haze. This is any confined layer of pollutants that creates a contrast between that layer and either the sky or the landscape that you can see behind it. And then the last one is uniform haze, which occurs most often when warm air causes atmospheric pollutants to become well mixed throughout all the air, and everything is dealing with the consequences of it. Okay. So again, from your clear day, you can see a plume haze, layered haze, or uniform haze, and all of those are going to go ahead and impact how well you can see. All right, the next thing I wanted to go ahead and talk to you about was acid rain. According to the EPA, acid rain, or more accurately, acid deposition, is a broad term that includes any form of precipitation that contains acidic components such as sulfuric acid or nitric acid. Remember, sulfur dioxide and nitrous oxides, these can react in the atmosphere, causing those primary pollutants to become secondary pollutants, creating the acid rain. Acid deposition typically has a pH lower than 5.6 and includes snow, fog, and dust, not just rain. To better understand acid deposition, we need to better understand some basic water chemistry. You may remember from your days in biology that the pH scale is a measure of hydrogen ions, or H plus ions. Acidic means there are more H plus ions in the solution than OH ions. Basic, however, is on the opposite side, which means there are more hydroxide ions in the solution than hydrogen ions. So the increases between the numbers going from 7 to 8, 8 to 9, 7 to 6, 6 to 5, so on and so forth, the numbers are tenfold. So going from 7 to 6, you have 10 times as many hydrogen ions as you do at 7. At 7, the hydrogen ions and hydroxide ions are even. Okay, this is basically based on water or H2O. If you take an OH minus and add it to an H plus, you end up with water. So the low side from 7 down to 0 is acidic. That's your acids, that's high hydrogen ions. Going from 7 to 14 is basic. The far end, more hydroxide ions than hydrogen ions. And so that's the scale that we typically use. Now, you may not think of it in terms of the scale, but you actually deal with acids and bases all over the place in your life. Almost every liquid that we encounter in our daily lives consists of acidic and basic properties, with the exception of pure water. Normal rain is slightly acidic with a pH of about 6, while acid rain generally has a pH between 4.2 and 4.4. But before you start thinking, oh my gosh, that's so acidic, realize that we deal with things that are more acidic than that also on a routine basis. Tomato juice, if you've ever had pasta, right, or that sort of thing, is actually more acidic than acid rain. Lemon juice is even more acidic than that. Okay. So when I was a kid, one of the things that was common to do in the summer was to put a little lemon juice in your hair and sit out in the sun, and it would actually kind of bleach out some of the color. That's how strong it is. And stomach acid, which helps you digest your food, is even stronger acid. So as we get down to 1.5 for stomach acid, we start realizing that that's more acidic than anything above it there. On the other end, we've got all these things, look, seawater, human blood, soap, ammonia. You'll notice a lot of cleaning solutions on the basic side of the spectrum. Okay. Some common examples of acids include lemons, oranges, vinegar, urine, sulfuric acid, hydrochloric acid. Notice that hydrochloric acid has that H right there. Acids tend to have hydrogen by itself when you're looking at a chemical formula. We also have some examples of common bases: soap, toothpaste, bleach, cleaning agents, lime water, ammonia water, sodium hydroxide. Notice that with sodium hydroxide, bases tend to have hydrogen with oxygen as that OH or hydroxide group. Okay. All right. So at this point in time, I want you to go ahead and pause this video, go watch the video on acid rain, and then we'll go ahead and pick up after that. Remember that this video is part of your notes, so make sure you're taking notes on the video as well. Okay, so what are the causes of acid rain? Okay, rotting vegetation and erupting volcanoes release some chemicals that can cause acid rain, but most acid rain is a product of human activities. The biggest sources are coal-burning power plants, factories, and automobiles. When humans burn fossil fuels, they release sulfur dioxide and nitrogen oxides. Remember NO2 or NO, nitrous oxide, nitrogen dioxide. All three of these are primary pollutants that react with water vapor, oxygen, and other substances to form airborne sulfuric and nitric acid. Those are secondary pollutants. And as we mentioned before, with air and water, a lot of our pollutants don't stay put. So pollution in one place is a pollution in every place, right? Pollution here is pollution everywhere. And so this is a problem that we all share, and we need to realize how interconnected our waterways and our air is. Wind may spread these acidic compounds throughout the atmosphere and over hundreds of miles. So the damage that you do to the air here may cause pollution to fall in a nearby neighboring city or even in another country, especially when we look at smaller countries across Europe. When acid rain reaches Earth, it flows across the rivers and lakes and streams and enters our water system and sinks into the soil. So you can see how acid rain would impact both land and water pollution. So how does that form? Again, you've got all these sources that we've talked about before. They're emitting things into the atmosphere, especially our nitrogen oxides and sulfur dioxide. Those are transformed from primary pollutants into secondary pollutants, nitric acid, sulfuric acid, and those then either come down as acid precipitation, right? Or they have dry fallout and cause problems. So what does that look like? We can see the impact on things like human statues, on fish populations, on tree populations. In this picture on the right here, this is a graveyard of Norway spruce trees in Poland. And you can see the impact of acid rain. You know, all the needles have basically been torn off of the plants. The trees become weak because the nutrients are not dissolving at the same rate. The roots get weak of the trees and they tend to kill themselves. So sulfur dioxide and nitrogen oxides are not primary greenhouse gases, which we'll talk more about in the second half of this semester and unit, but one of the main effects of climate change. In fact, sulfur dioxide has a cooling effect, but nitrogen oxides contribute to the formation of ground level ozone, a form of smog, which we'll talk about in here in a minute, and is a major pollutant that can be very harmful to people. Both gases have huge environmental and health concerns and can spread easily via air pollution and acid rain. So what are the environmental effects? Acid rain and fog can damage forests, especially the higher elevations, can rob the soil of essential nutrients, especially things like calcium and aluminum, and kills good bacteria. Damages tree roots, leaves, and needles, and combined with other environmental stressors can leave trees and plants less healthy, more vulnerable to cold temperatures, insects, and disease. The pollutants may also inhibit the tree's ability to reproduce. So not only are you damaging the trees that are here, but you're preventing other trees from showing up. In humans, acid deposition can damage physical structures like the statue we showed you before. It can damage cars, buildings, monuments. It can corrode copper and lead piping, then letting that lead leach into our water supply. And when it takes the form of inhalable fog, acid precipitation can cause health problems like eye irritation, asthma, and it tends to cause toxic metals to move, which can also cause problems for us. Air pollution includes greenhouse gases like carbon dioxide, and they can warm the climate, trapping the heat of the sun. Greenhouse gases are a natural part of the atmosphere, but their increasing amounts in our atmosphere have gone up dramatically since the early 1900s, causing our climate to warm at a faster rate than naturally it would because of the human contribution. We'll talk more about greenhouse gases and climate change in upcoming classes, which leads us to this concept of smog. So most of you have heard this before, and you usually think about like LA. The term smog is a combination of smoke and fog and is a severe form of air pollution. There are actually two types of smog, sulfurous and photochemical. Sulfurous is a result of industrial processes like coal burning and the production of large amounts of sulfur dioxide. This is the stereotypical pea soup fog that you're used to seeing when you think about smog. Sulfurous smog generally occurs in areas where there's more industry and places rely heavily on fossil fuel burning for energy and heating. Photochemical smog, or ground level ozone, is generally found in urban areas and industrial areas and occurs when hydrocarbons from vehicle exhaust react with sunlight to produce ozone. Tends to be a little more hazy, a little more yellow. This is the type of smog typically found in cities, particularly busy intersections and areas with high vehicle traffic. To learn more about these two types of fogs and air pollution in general, please go ahead and watch Air Pollution 101 from National Geographic. At this time, pause the video and go ahead and watch the air pollution video. Again, this is part of your notes, so please take notes as you're watching it. I want to finish today by going ahead and taking a look at some solutions. There are several solutions to stopping man-made acid rain. Regulating the emissions coming from vehicles and buildings is an important step, according to the EPA, and this can be done by restricting the use of fossil fuels and focusing more sustainable energy sources such as solar and wind power. Also, every person can do their part by reducing their vehicle use. Use public transportation, walk, ride your bike, carpool. These are all great places to start. People can also reduce their use of electricity, which again, in most of the country is primarily produced through fossil fuels, and switch to a solar plan or at least a renewable energy plan. For a couple extra cents per kilowatt hour, you can go ahead and purchase a clean plan from eWeb or Sub or whatever your electrical company is in your particular area. Okay. But it's not just about acid rain and slowing down acid rain, all forms of air pollution. There are steps you can take to get involved at home. Remember, pollution here is pollution everywhere. Pollution there is pollution here. This is because air pollution can travel long distances. So the clean air actions that you take at your home will help parks have clean air and cleaner views, not just here in Eugene, not just at Springfield, but across the state of Oregon and even in other parts of the United States and potentially the world. Okay. If you want to improve air quality, here are some recommended actions that will have multiple benefits. The actions below will help you save energy and money while reducing your waste and reducing air pollution. Number one, green your ride. Combine trips, carpool, ride your bike, walk, take public transportation. Okay. Observe speed limits, avoid idling, maintain your vehicle so it's in the best shape possible. Remember, this was something we also talked about with water pollution. One of the biggest problems in terms of oil pollution is from not keeping your vehicle maintained. Consider driving a more fuel efficient or hybrid or even electric car. We have so much of our electrical grid in the state of Oregon coming from renewable energy sources that this actually is a very viable option if you want to be cleaner. Number two, reduce your power. Switch out to CFL or LED light bulbs. I love the LED light bulbs. They even have cool options now where you can change their colors and things like this. But if you do that, they use far less energy than standard A9 or A4. What is the number? I can't remember off the top of my head. Our standard light bulbs. Okay. And when you're not using an electrical device, turn it off. Okay. If you have it plugged in, most things go into a standby. So if you're really not going to use it for a while, completely unplug it so that you're not drawing any electricity from the grid. Okay. Number three, get comfortable. Insulate your home and use programmable thermostat to reduce energy used for heating and cooling. And in most cases, it is better to keep your house at a constant temperature than to have it kick up and down and fluctuate in terms of its temperature, because it's more work to heat up a cold house than it is to maintain a standard temperature. All right, number four, be food smart. We talked so much last semester about the impact of agriculture. This is one of the most impactful activities that we do is eat. And the food production system, whether it's meat or plants that we currently use, is just not very sustainable. So picking things that are more local, understanding the environmental impacts of your food choices, wasting less food are all great ways to go ahead and help be better green in terms of your decisions and choices. Okay. Number five, reduce, reuse, recycle. I know you've been hearing this one since you were really young, but this is one of the best things you can do to go ahead and prepare yourself to have a more sustainable lifestyle. And one of the best things we can go ahead and do to not overuse anything. Okay. Takes energy to make and sell all the products that we use. So you help reduce waste by sorting and recycling all the materials you can according to local programs and guides. We now can recycle more plastics. We were doing really well, and then China stopped taking our recycling a little bit before COVID hit. And then with COVID, we started switching to all these single-use plastics again. now we can start recycling more. Okay. We can now recycle ones and twos of any type. Just make sure you clean them out. This is part of the reason we lost recycling in the first place. We didn't do a good job cleaning them, but we can cycle ones and twos. Refill and reuse your travel mugs and water bottles instead of buying bottled water. Okay, we have all these awesome bottle refill stations across the school. Please take advantage of those. And then lastly, share your story. Tell a friend what you're doing for clean air. Tell what they're doing for clean water. Your voice is a powerful tool to convince others to make the changes we need to have a cleaner future. Okay. And that's what I've got for you guys today. Okay. Take care of yourselves, stay healthy, stay safe, and I'll talk to you soon. All right. So long. Bye bye.